Today, inshallah, we are going to continue the ordinary differential equation of first order. We are doing the questions on exact differential equations. Now, next type we have to start type 2 questions. Okay, in the previous class we have done questions on type 1. This is type 2. Suppose this m dx plus n dy is of the form y f of xy dx, y f of xy dx, x some another function g of xy dy, y dx x dy, f of xy g of xy means a function in which x and y are together, a function in which x and y are together. If this type of question is there, we have to find the integral factor. The integral factor is 1 divided by mx minus ny. See here two examples I have written here. Okay, let me see these two examples. You see how to find y xy dx, x xy dy here dy equals to 0. X and y will get together here, okay, as a single x dxy function will be together here. Y xy dx x xy dy. Here also you see y dx x dy, and the function is with xy together here, xy joined together here. So let me do this two questions inshallah. The first question we will try now. Now see on the board the question is written. First let me compare this one with m. This is m, this is n. So m value is y into x square y square plus 2, and n is n into x into 2 minus 2x square y square. You first multiply this y into y square will be y cube x square y cube plus 2 into y 2y. N equals 2 into x 2x minus 2x square into x cube y square. Now how to find exact? We have to find dou m by dou y, dou n by dou x. If these two are equal, we say this is exact. So let me compare this one, find this one, dou m by dou y. With respect to y, differentiation of y cube is 3y square. Y cube is 3y square. So we get like this 3x square y square. Differentiation of y is 1. So 1 into 2 is 2. Here also let me differentiate dou n by dou x. Differentiation of x is 1. 1 into 2 is 2. Minus differentiation of x cube is 3x square. So 3 2s are 6 x square y square. You see these two are not equal. Therefore we write dou m by dou y is not equals to dou n by dou x. Now the given question is of the form. Question is of the form y into f of xy dx plus x into g of xy dy equals to 0. So for this we are having integral factor. Integral factor, we know the formula of integral factor, 1 divided by mx minus ny. 1 divided by the value of m is here x square y cube plus 2y into x minus of n into y. The value of n is here 2x minus 2x cube y square into y, mx minus ny. Let me solve this one. 1 divided by, now multiply with x. So this x into x square will be x cube y cube plus 2xy minus into plus minus 2x into y, 2xy minus into minus plus 2x square y square into y, 2x cube y cube. So this will get cancelled. Now 2 plus 1 is 3. So we get this one 1 by 3x cube y cube. So this is the integral factor. Now if we multiply the question with the integral factor, we'll get the exact form. So you take this after multiplying. What is the question? You see here When we multiply it with y, see here the value of m is x square y cube plus 2y into dx, plus the value of n is, you multiply this 2x minus 2x cube y square. So I have written here into dy equals to 0. This is the question. Now we have to multiply by integral factor. The value of integral factor is 3x cube y cube. So let me multiply this one. Okay, so multiply each term. See here we are having x square y cube. We are multiplying with 3x cube y cube plus 2y. We are multiplying with 3x cube y cube. This is dx plus 2x by 3x cube y cube minus 2x cube y square by 3x cube y cube dy equals to 0. Now see what is left after cancellations. Let me write the remaining terms. See here, if we cancel this one, x cube y cube, it can cancel, and x square x, we left with 1 by 3x plus here 1 will get cancelled, 2 by 3x cube y square dx plus c here, if we get cancelled, this is left with 2, so 2 divided by 3x square y cube minus y cube will get cancelled, and this is left with 2 divided by 3y dy equals to 0. Now again let me suppose this one m1, this is n1, so m1 equals to 1 by 3x plus 2 divided by 3x cube y square. See, let me do one thing. This is n1 equals to 2 divided by 3x square y cube minus 2 divided by 3y minus 2 divided by 3y. Now you do one thing. It's not necessary to again show that this is exact. Always after multiplying with integral factor, we always get the in the exact form. If we do prove, we go to prove this one, it will take long time, it will becomes lengthier. Okay, anyhow this one will be exact, so we can use the formula. The solution is integration of m1 dx plus integration of n1 dy equals to c. Here we are having y constant, and here we are having the terms which not contain x, not contain x. So let me continue. Integration of m1, the value of m1 is 1 divided by 3x plus 2 divided by 3x cube y square dx plus, now the value of here n1, we do not write the term which contain x, we do not write the term which contain x. So what is left here? Here we left with minus 2 by 3y dy equals to c. You see here there is one thing only to understand here, how to integrate. Integration of 1 by x cube, bring this up in the numerator, it will be x power minus 3, x power n will be x power n plus 1 by n plus 1, so it will be x power minus 2 by minus 2, that will become, bring this in the denominator, will become plus 1 by minus, you write here 2x square, 1 by 2x square, 1 by 2x square. Now see here, I am writing 1 by 3 as it is, 1 by 3, 1 by 3. Now integration of 1 by x is log x, integration of 1 by x is log x, so write this as log x plus 1 by 3 as it is, integration of 1 by x log x. Now here we have to integrate this 1 by x cube, you write this as it is 2 by 3y square, 2 by 3y square, 2 by 3y square. Now integration of 1 by x cube, just we have done, it is minus 1 by 2x square You write minus 2 by 3. The minus 2 by 3. Integration of 1 by y is log y equals to c. Now the last step is this 2 will get cancelled. What is left here? 1 by 3 log x plus into minus minus 1 by 3x square y square minus 2 by 3 log y equals to c. So we have completed the question. Next question, I wrote few steps. I written few steps to reduce the time, because if we do long, the video will be too lengthy. Okay, I'll explain you every time. See here. First, let me compare. This is m. This is n. Now, next step, you multiply this with y into y square, y into cos xy. Here you multiply with x into x square y sin xy, x into cos xy. Now you see here, if we go on prove to see whether it is exact or not, it takes lengthy, because to find dou m by dou y uv get very lengthy. Dou n by dou x uv we can do directly, because it's of the form y f of xy y dx g of xy x dy. So we directly find the integral factor. Okay, to prove exact or not, it take lengthy time, because it's already in the form. We can take directly 1 by mx minus 1 by this is mx minus n y. So multiply x into x square, x into y xy. In the same way, y into y square, x into y xy. Now you see here, we get cancelled this one, plus x square y square sin xy minus x square y square cos xy. So what is left here? Xy cos xy plus xy cos xy will be 2xy cos xy. So we get here the integral factor. We got the integral factor. So let me multiply with every term with the integral factor. So multiply this with integral factor, multiply this with integral factor, all the terms of the question. I wrote once more the question. Now I multiplied every term with the integral factor. Now see here what is left here. So of the cancellations, you see this x will get cancelled, y square will get cancelled. What is left? Y by 2 tan of xy. Here if you cancel cos cancel, y cancel 1 by 2x. You cancel it, y cancel, x square cancel, x by 2 tan xy minus, if you see here cos will get cancelled, 1 by 2y. Now what is the formula we have? Integration of m1 dx plus integration of n1 dy equals to c. Here we take y constant, and here we do take terms which do not contain x. Free of x, terms free of x. I'm writing it short, okay? So let me continue now. Integration of m, we write the complete term. Y by 2 tan xy plus 1 by 2x dx plus integration of, see here, we do not write all the terms. We write the terms which do not contain x. Because it contains x, we do not write this term. We write only minus 1 by 2y dy equals to c. Once more, watch here. Minus 1 by 2y dy. We are not writing because this term contains x. Let us see once more. What is the formula of integration of tan ax? Suppose integration of tan x is log of secant x. See here, integration of tan x is log of secant ax. Integration of tan x is log of secant x. But whenever in integration we are having some constant here with x, coefficient of x, we have to divide by this a. This a is constant with x, so we have to divide this. Integration of tan is log of secant x, but with x we are having a, so divide it. In the same way we are doing here. You see here, let me do this one. So integration of this y is constant, we are integrating with respect to x, and we are feeling y is constant, so you write y by 2 as it is. Now integration of tan x is log of mod secant xy. Now watch carefully, because we are integrating with respect to x and y is constant here, y is constant, so we have to divide by y plus, see here, 1 by 2 we write as it is. Now integration of 1 by x is log x log of mod x minus 1 by 2. Here also you see here integration of 1 by y is log y. Because we are getting all the answer in log, we suppose this constant also log c. Remember this one. Whenever we get the answer, complete answer in log, it's better, easier to suppose constant also in log c, not just c but log c. Now this 2 will get cancelled. You see we are having 1 by 2, 1 by 2, 1 by 2. Let we take constant common. So what is left here, watch carefully, log a plus log b minus log c, like this. Log a plus log b minus log c. So we can write log AB by C. This minus will go down. This will be the formula, log AB by C. Log AB by C. Watch carefully. Once more I will explain. Because we have taken common, what is left here? 1 by 2 we have taken common. Log, suppose this is A plus log B minus log C. This will become log of AB. AB means secant xy into x, secant xy into x divided by y, log AB by C equals to log C. Now bring this 2 here. The place here is very less, so I am continuing it. If you bring this 2 here, it will be like 2 here. Now bring this 2 in the power here, it will be log C square, log C square. So log will get cancelled. What will left here? X into secant xy divided by y equals to c square. Brought c here, we brought this 2 here, then log will get cancelled. Now the last step is bring this y here, so the answer will be x secant xy equals to c square into y, c square into y. Now see next type questions, type 3 type for same method. Suppose we are not having the homogeneous linear equations nor the second time, then we will check for this. Watch carefully. Dou m by dou y minus dou n by dou x by n. If we get this value as a function of x alone, means we are getting here only x value, not y, only x value. Value of this is only in terms of x, then the integral factor will be e to the power of integration f of x dx. Then the integral factor will be e to the power of integration f of x dx. If this case is not satisfied, let me change into another form. We can change it another form. The reverse of this. Dou n by dou x minus dou m by dou y. Dou n by dou x minus dou m by dou y by m, not n by m. If we get this value only in terms of y function, get only in terms of y, not any term of x, then the function of y alone, then the integral factor will be e to the power of integration f of y dy, e to the power of integration f of y dy. So let me do one or two questions like this. Now see here, let me do one question. Already I wrote few steps here. The value of m is x cube plus y cube plus 1. The value of n is xy square. So if you find dou m by dou y with respect to y, we don't have y here 0. This is constant 0. Y cube differentiation is 3y square. With respect to x here, so d by dx of x is 1. 1 into y square is y square. These two are not equal, therefore we say it is not homogeneous. Now watch here, it's not it's not exact form. Also this is not of the form type 1 homogeneous, not type 2. So let me try for this. Okay, we are now having two formulas. One is dou m by dou y minus dou n by dou x divided by n. Let me find this one. If we get this value in terms of x alone, then there will be a formula. If it's not equal to x alone, then we can do a one more, dou n by dou x minus dou m by dou y by n. Let me first try this one. Okay, equals to dou m by dou y. Dou m by dou y is 3y square minus dou n by dou x is y square divided by n. The value of n is xy square. So this is 2y squared by xy squared. Y square will get cancelled, you left with 2 by x. That is, the function is in terms of x alone. X alone. So this we called as f of x. This is f of x. So the integral factor will be, now because we get the function in x alone, therefore we can take the integral factor as e to the power of integration f of x dx. So e to the power of integration f of x is 2 by x dx. So e to the power of, take out this 2 outside, integration of 1 by x dx. E to the power of 2, integration of 1 by x is log x. Bring this 2 in the power, e and log will get cancelled. So we can write this e to the power of log of x square. E log will get cancelled, left with x square. Now we got the integral factor as x squared. Now if we multiply the question with x squared, it will become exact. What is the question we are having? X cube plus y cube plus 1 dx plus xy square dy equals to 0. Now multiply by x square. If we multiply by x square into x cube, it will be x power 5 plus x square into y cube will be x square y cube plus x square into 1 will be x square dx plus, if you multiply with x square, it will become x cube y square dy. Now it will change into exact form. Need not necessary to show that it already changed into, we can show it or we can leave the step. Now let me consider this as m1 x power 5 plus x square y cube plus x square. Now consider this as n1 x cube y square. The question is so easy. Now let me show whether, let me see whether it is exact or not. The dou m1 by dou y with respect to y, we don't have y here 0, we don't have y 0 here. Y cube will be 3y square, so this will be 3x square y square. Dou n1 by dou x, x cube will be 3x square, so 3x square y square. You see, we got the equal values, therefore it is exact. Now the formula is integration of m1 dx plus integration of n1 dy equals to c. Here we take y constant and here we take terms not containing x. Okay, now let me continue this one. Now integration of m1, the value of m1 is x power 5 plus x square y cube plus x square dx plus integration of, we will not take all the terms of n, we take only the terms of n which do not contain x. But you see here it contains x, so we don't have any terms, so you just take 0. We have to take n1 terms only which do not contain x, but we are having only one term which has x, so there is no term, so 0. Now integrate this one, integration of x power n is x power n plus 1 by n plus 1. So this will become x power 6 by 6. Now x square will become x cube by 3. This is constant, right, as it is. Plus again integration of x square will become x cube by 3. This is 0, now equals to c. So if we take LCM c, 6 will go here. What is left here? Okay, let me take LCM 6. So this will be x power 6 plus 3 into 2. No, you will get 2 here. 2x cube y cube plus 2x cube equals to c. Bring this 6 here and take common from this all. We can take common x cube. So if we take common x cube, it is left with x cube plus 2y cube plus 2 equals to 6c. Now see here, next question. I wrote few steps here. Suppose m equals to y power 4 plus 2y and n equals to. Let me find dou m by dou y with respect to y. Y power 4 will be 4y cube. Dy by y will be 1. This is 4y cube plus 2. And see here, with respect to x is 1, 1 into y cube is y cube minus 4. So these two are not equal. Dou m by dou y is not equals to dou n by dou s. It is not of the exact form, also not of the form type 2. So let me try for this. Dou m by dou y minus dou n by dou x by n. Dou m by dou y value is 2, 4y cube plus 2 minus y cube minus 1s plus 4. But we are not getting the function in x alone. We are not getting the function in x alone. So we next try for the next one. You have to see like this in the rough. Okay. So let me try for the next. What is next here? Dou n by dou x minus dou m by dou y divided by m. We are trying for the next. So this value is y cube minus 4. Minus means we have to multiply this with minus. So this will be minus 4y cube minus 2 divided by m. The value of m is y power 4 plus 2y. Now this you see here, y power 3 minus 4y cube is minus 3y cube. Minus 4 minus 2 minus 6 y power 4. Let me take common y here. If you take common y, it is left with y cube plus 2. In the numerator also you take minus 3 common. If we take minus 3 common, it will left with y cube plus 2 divided by y into y cube plus 2. Now you get cancel this one, left with minus 3 by y. So this is the function in y alone. This is the function in y alone. Therefore, now we suppose this as f of y. Now the integral factor equals to e to the power of integration f of y dy. E to the power of integration f of y is this one minus 3. Take outside, left with 1 by y dy. E to the power of minus 3. Now integration of 1 by y is log y. Now bring this minus 3 in the numerator, in the power, we get cancelled e and log. So e to the power of log y power minus 3. E log will cancel, what is left here? Y power minus 3. Therefore integral factor equals to y power minus 3. Or we can write 1 by y cube. 1 by y cube. Now we multiply the question with 1 by y. What is the question here? Y power 4 plus 2y dx plus xy cube plus 2y power 4 minus 4x dy equals to 0. Now you have to multiply with this one. So if we multiply with 1 by y cube, it will be like this: y power 4 by y cube plus 2y by y cube, this is dx, plus xy cube by y cube plus 2y power 4 by y cube. Now let me cancel this one. Y cube will get cancelled, we left with y. If we cancel this, we left with y square in the denominator dx, plus if you cancel this, left with x. Cancel this one, left with y minus 4x by y cube dy equals to 0. Now consider this as m1, this as n1. m1 equals to y plus 2 by y square. n1 equals to x plus 2y minus 4x by y cube. Now let me again check whether it will be always exact form. Whether we check and show or it's not necessary to show. Let me see, question is easy. Dou m1 by minus, it will become minus y cube, and no need to show that we have to bring upstairs and differentiate. Let's use directly formula: integration of m1 dx plus integration of n1 dy equals to c. Here we take y constant, here we take terms which do not contain x. So integration of this is y plus 2 by y square dx, plus here we have to take only terms which do not contain x. This contains x, will not take, this is also x, we left with only 2y equals to c. Now here we have to integrate with respect to x. Here we don't have x, it is y, so we must consider y as constant and take 1 as integration. So integration of 1 will be x, so it will become xy. Here also we have to integrate with respect to x, but we are having only y, so we differentiate 1. 2 into 1 we feel integration of 2 will be 2x. So this will become 2x by y square. So plus 2 into integration of y will be y power n plus 1 by n plus 1, that is y square by 2 equals to c. This we get cancelled. We can leave here itself x y plus 2x by y square plus y square equals to c, equals to c. So inshallah we will continue in the next class. You practice these questions, inshallah we will continue in the next class, inshallah, next types of questions.